How do you find the projection of a vector onto another vector? So this standard notation over here, projection of u sub v, that basically means you're finding the projection of u onto a vector v. So to draw this out, let's take a look at vector u. Let's say it looks like this. And we're going to see how it looks when you project it onto this vector, vector v. So that's going to be right here. And what it would look like, I'm going to put this in a different color so you can see. It would essentially be the component of u that lies along v. So that would look something like this over here. Right, so that's all it is. And we want to find this. And over here, it doesn't look too difficult. Actually, there's a pretty simple formula for it. I'm going to do this in blue. If you let this angle here be theta, all this is going to be is the magnitude of u times cosine of theta. That's going to give you this length. And of course, since it is a vector, we also want to give it a direction. And the direction will be the direction of v. We can't multiply it by the unit vector v, right? This is first of all a scalar, right? So we can't multiply it by that vector because this has a magnitude that might not be 1. But we can multiply it by the unit vector in the direction of v, which we denote like this, v hat. Now, we need to try to express this in a more convenient way because we don't really know what theta is. We don't want to include theta. That makes it unnecessarily, complicated. But we do know that cosine of theta, and theta is between these two, between vector u and v, is nothing but u dot v, right? So this is the dot product divided by the magnitude of u times the magnitude of v. So we can plug this in. Before we do that though, let's take a look at v hat. That's nothing but v, right? The vector v divided by its magnitude. And that's going to essentially normalize the vector and just give you the unit vector in that direction. Now let's plug all this back in here. So we have u times it's not a dot product, so I'll just not, okay, sorry, I'll do it on a new line. It's u times u dot v divided by the magnitude of u times the magnitude of v. We're multiplying this by the vector v divided by the magnitude of v. We can see that the magnitude of u cancel out, leaving us with u dot v. We can bring this in over here, divided by the magnitude of v squared. And then all of this is going to be a scalar because the dot product on top here is going to be a scalar. And of course, this is a magnitude squared, so it's also a scalar. And we're just going to multiply that by the vector v. And this is equal to the projection of u onto v. And just like that, we're done.